Okay, so yeah, here we go again. Okay, so I'm sorry medyo late na tong video, but I hope magamit niyo pa rin. Okay, but anyway, so let's continue with the topic at hand here. So we have the topic is statical stability of floating bodies. So ano bang ginagawa natin sa gagawin natin sa topic na ito, ano? Basically, we're just going to determine whether a certain floating body will float in a stable or unstable manner. So how do we do that? So let's try to discuss it in here. Okay? So, illustration natin dito. So we have three conditions in here sa illustration natin. So when do we say that a body is stable and unstable? No. When do we say that? That is when the metacenter of the body, when the metacenter is higher than the center of gravity, then the floating body is stable. So ano ba yung metacenter? Metacenter is the intersection of yung line of action ng buoyant force and yung center line ng body. So again, metacenter is the intersection of the line of action of buoyant force and the center line of the body. So if M is higher than G, as illustrated in here, if M is higher than G, then the moment created by the couple, no, so a floating body, when the body floats in a fluid, basically the buoyant force is equal to the weight. No? So equal yung dalawang forces na yan. So they create a moment. So if you try to analyze the moment created by this couple, it's actually a restoring moment. So it would make the body stable. No? The moment would make the body stable. Okay. So ganon. Kapag unstable yung body, kapag yung M or we call it the metacenter is higher than G. And unstable siya kapag yung M is lower than G. So M, we call it the metacenter, is lower than G already. So the moment created by this couple is actually an overturning moment. You can visualize visualize it using this figure. So the moment would tend to overturn, make the body roll over and over and over and over dun sa liquid, ano. So the indicator then is the location of M. So solve natin later on. So the indicator is the location of M. So if M is higher than G, then it is stable. If M is lower than G, then that is unstable. Now we have a third condition here. That is when the weight and yung center line ng body is or yung weight I should say, the weight is collinear. Yung weight and the buoyant force are collinear. So the two forces are collinear. We call this condition just stable. So sakto lang, stable siya. Okay, so that's it. So our indicator would be the location of M. So let's discuss this further. Now we have this illustration. Now I hope you have your handouts with you or the module. Ano? So medyo shorten natin itong discussion ng derivation ng formula para hindi sayang yung data nyo sa panonood ng video. Anyway, I decided to use this illustration. Sabi ko kanina, if M is higher than G, then it is stable. If M is lower than G, unstable siya. Based from this figure, based from this figure, kasi later on we will be solving for MBO. Ano yung MBO? MBO is distance between the metacenter and the center of buoyancy. Sige, discuss muna natin itong figure para malito kayo. No? So, ano yung mga elements of a floating body? We have the weight, acting at the center of gravity, of course. The buoyant force, okay, always equal to the weight, ano, since it is a floating body. Okay, ito. G is the center of gravity. Okay. And by the way, G is not, the center of gravity is not always equal to the center of gravity of the the the, the shape, ano. Sometimes loaded ito, loaded yan. The center of gravity would shift, ano, tataas yan. Kung, for example, this is a barge or a ship, bangka, for example. Kung may load yan, yung center of gravity niya would shift. And hindi na yung centroid ng shape, but since loaded siya, may mga karga siya, the location of center of gravity would somehow shift upwards. Ano? Okay? So, that center of gravity is G, and then BO is the center of buoyancy and the upright position. Okay, usually the centroid only displays liquid. So, if this is the displaced liquid, yung centroid niya, yan yung center of buoyancy. Okay? So, BO is the center of buoyancy in the upright position. Hindi pa siya nag-tilt. Kasi may possibility na mag-tilt siya, especially with the action of waves or wind or unequal, unbalanced loading ng karga sa taas. So, pwedeng mag-tilt yung floating body. Okay. BO prime is the center of buoyancy in the tilted position. So, pag nag-tilt siya, mag-shift mo yun yung location ng center of buoyancy. We call that the BO prime. And VD, volume displaced volume. Ito. Okay, sa upright position ito. Ito pag tilted position. Okay, M, as I've said a while ago, metacenter, the point of intersection between the line of action of the buoyant force and the axis, central axis ng body. C, small letter C, center of gravity of the wedges. Importante ito sa derivation ng formula natin later on, but I will no longer be presenting about derivation to save time, ano. And S would be horizontal distance between the center of gravity of the wedges. Ito. So, gamitin din sa derivation. Small letter V is the volume of the wedge immersion. Ito. Itong triangle na yun, dalawang triangle. The angle of tilt. Ito. So, angle of tilt yan. Equal yan dito sa angle dito. Okay, yung angle theta, equal dyan. Siyempre, ano, transfer ka ng angles. MBO is distance between M and BO. So, the distance between the metacenter and the center of buoyancy. That's MBO. And then GBO, distance between the center of gravity and center of buoyancy. MG is the metacentric height, distance between M and G. So, MG, metacentric height, distance between M and G. Yan. Okay, so sabi ko kanina, if M is higher than G, then stable yung floating body. If M is lower than G, then unstable siya. Okay, so from there, we can say that when MBO, ito, distance ng M, metacenter, and center of buoyancy, if MBO is greater than GBO. Ano ang GBO? Distance ng center of gravity and center of buoyancy. If MBO is greater than GBO, then stable. Okay, so I repeat, if MBO is greater than GBO, then stable siya. Again, and on the other hand, if MBO is less than GBO, pag mas malaki yung GBO compared sa MBO. So, if MBO is less than GBO, that means M is lower than G, then the body is unstable. So, that's how we tell, no, kung stable ba or unstable yung floating body. So we can also compute for the righting or overturning moment. Ano? So based from the figure, so since may couple dito, couple, so the weight is equal to the buoyant force. So basically, they would create a couple, moment of a couple. So how do you compute for the moment of a couple? That's the force, so either weight or buoyant force, they are just the same, times the distance between the two forces, which is in this case x. No, if mg is a metacentric height, then x is equal to x mg sine of theta. So right triangle yan. Okay. Opposite side itong x. So x is mg sine theta. That would make the righting or overturning moment equal to weight or buoyant force times mg sine theta. Okay, so that's it. So basically, we are just going to compute for the values of MBO and GBO to tell whether the body is stable or unstable. And then if you're interested to solve for the righting or overturning moment, then we need to solve for mg or the metacentric height and the angle of tilt. So ganun lang naman. Kasimple. Okay? So, yun na. So, how do you solve for MBO? So, hindi ko nilagay yung derivation dito. So, MBO is equal to, for any cross section, MBO is equal to I over BD. Moment of inertia over the displaced volume. So, anong moment of inertia ito? Yan yung moment of inertia ng shape na nakat ng liquid. So, ito yung liquid, ano? So, yung shape ng nakat niyan, yung shape niya along the horizontal direction, yung moment of inertia nun, yun yung I dito. Okay? And of course, the displaced volume, over displaced volume. Yung displaced volume, ito, yung nasubmerge sa liquid. Okay? So, that's I over BD. So, this is our general formula. And then, from here, we can derive the formula for rectangular section. So, mostly, we're going to analyze scows and barges, which is in the form of a rectangular parallelepiped naman. So, for rectangular section, that's equivalent to MBO is equal to LB cubed all over 12 all over BD. So, ito yung ating I, L, B cubed all over 12. Ano yung L? Going back to the figure, ito yung L. Yung long direction. Itong B cubed. Ito. Basically, ito yung height, base, B, H cubed. Yan. All over 12. Over volume displaced. Or, it's equivalent to, ito, kapag may angle of tilt siya, so, inclusion ng angle of tilt, yan. Or B squared all over 12D times the quantity 1 plus tangent squared, theta all over 2, yan. So, that's it. So, MBO, and then we solve for GBO by inspection. And then compare natin yung dalawang values. If MBO is greater than GBO, then stable. If MBO is less than GBO, that is unstable. So, ganun lang kadali mag-identify kung stable ba or unstable yung body, floating body. Okay? So, that's for the brief introduction of the topic. We will have a separate video for the illustrative problems. So, see you sa next video.